Okay, this video what we're going to do is discuss the different types of connective tissue. And we're going to look at three different primary categories of those tissues and focus or drill in a little bit more on each one. Now, in class and in the previous video, I talked about the different types of cells in connective tissue. One of those cell types is a stem cell, which can differentiate or specialize into other types of connective tissue. And if you recall, that was known as mesenchyme. And mesenchyme can differentiate into all the different types. So let's look over here. And the first one we're going to look at, it can be connective tissue proper. So I'll just do CT proper. We're going to have a second type, which can be supporting connective tissue. Supporting connective tissue. And your third type, well, that's a really straight line, will be a fluid. That's an F, really. Okay. So a fluid connective tissue. Looking at this last one first, okay, this is the easiest one to consider on here. And what we're looking at, fluid connective tissue is essentially just blood. Okay. In your textbook, you will also note lymph. Lymph is essentially, and we're going to get into much more detail down the road, but the plasma within your blood leaks out of the blood vessels. It comes or it goes into the interstitial space. Interstitial space is the space around the cells, and then it's at that point it's called not plasma, but it's called interstitial fluid. That interstitial fluid is then picked up by your lymph system, and it becomes lymph. Okay, so there's some subtle differences between all those fluid, but it's still fluid nonetheless. Now, lymph doesn't have any cellular components. Okay, blood does have cellular components, so fluid connective tissue would include lymph. So let's go back and look at connective tissue proper. Connective tissue proper can come into two different flavors. We've got dense, and then we have loose. Okay, so those are your two types of connective tissue proper. Now let's drill down on each one a little bit more and look at what are the different types of dense. So let me kind of do it like this. So dense can be broken down into regular. And dense regular tissue is going to be made mostly of like those lasagna type noodles, the collagen fibers on this one. And they are going to resist stress in one direction, so they're very strong. They're not going to be stretchy. They have very, very few blood vessels in them. And all the fibers are going to be nice, neat, lined up in one direction, okay? And you're going to find those in tendons and ligaments. So dense, regular connective tissue would be an example of that, would be the tendons and ligaments. Another example, if we have regular, then you're going to have irregular. Irregular connective tissue. And here, the collagen fibers are interspersed. They're in multiple directions, unlike dense regular, where if you were to look at lasagna noodles at the grocery store, if you put them on, they're all this wavy forms and they all line up. That would be dense regular. The dense irregular, you still have collagen fibers, but all the fibers are going in different directions. And the purpose of the different directions is it allows for strength and flexibility or resistance in multiple directions. So dense regular, you're going to find that in tissues like your tendons and ligaments. Dense irregular, you're going to be finding those in, say, the dermis of your skin. Because you're in dermis of the skin, you can move the skin in multiple different directions, and then that helps to provide some of that resistance. You will also find it in capsules of different organs. Okay, the kidneys. It has a renal, meaning kidney. It has a capsule that holds that together. That's going to be a dense irregular connective tissue. Here in another week or two, we're going to be talking with the skeletal system, and the lining of the bone is called a periosteum. That is going to be dense irregular connective tissue. We've previously said one of the characteristics of connective tissue, in addition to being highly diverse, okay, and we're starting to see connective tissue is going to be very diverse. On one hand, we have blood, and then the other one we're going to have tendons, and then shortly we're going to be talking about bone and everything in between. So it's highly diverse, and it's highly vascularized. Unlike epithelial tissue, which is avascular, connective tissue has a lot of blood vessels, except going to be cartilage. That's going to be an exception to the rule. And one of the things associated with poor vascular supply, if you injure a tissue, the speed at which it heals is dependent largely on your circulation. If you have circulation or if you have vascularity going to that tissue, it will heal faster than if you didn't have blood vessels going to that area. Cartilage doesn't have any blood vessels. So that's why the sprain injuries, or if you tear a meniscus of your knee or you tear an ACL, it takes a much longer time for those injuries to heal than if you just tear a muscle. Okay? So irregular tissue we covered. And then there's one more on this one, and you're going to see this actually in two different places on this. And this is going to be elastic tissue. And this elastic tissue are densely packed elastic fibers. It allows for stretching and recoiling, just like any elastic tissue would. And you would see, we previously discussed, you would see these fibers or this type of tissue, say, in the blood vessel walls, the artery walls on this one. So when you have a blood pressure, it expands, the elastic tissue brings it back down. You're going to see these tissues in your trachea. You're going to see them in your vocal cords. Those are common areas that you are going to see those types of tissues. Okay. Now, connective tissue proper, let's go down the direction for loose. And when we're looking at loose connective tissue, what we are dealing with, again, we've got three on the dense side. So on the loose side, let's go this direction, okay? So on loose, we are going to, let's just start with adipose. Adipose tissue, if you recall earlier, the cells are adipocytes, and those are fat cells, okay? They're kind of neat to look at, but not on your body, okay? So you're looking at that. Adipose cells has a lot of different functions. You're looking at, it's a reserve for energy, and it can be used as insulation. It can be used as cushion, okay? So there's a number of different functions for adipose tissues. You typically have a set number or a constant number of adipose cells in your body, and weight gain or weight loss is not adding more cells or taking away cells, but it's actually making those cells larger or smaller. And just recall, the nucleus is pushed to the side of the adipocyte, and the majority of the cell is a droplet of fat or is a droplet of triglycerides, and that's what's going to be the adipose tissue. The other one, what we're looking at on here, would be irregular. Areolar. That is an E. Okay, can't really see it. But areolar tissue. And areolar tissue is a loosely organized tissue. Let me just clean this up here. It's a loosely organized tissue that has a lot of space in between it. It can be, or it is highly vascularized. It's like the packing material of your body. It kind of holds everything together. It's a very loose tissue. If you ever look at a piece of raw chicken, and if you were to slowly tear off the layer of skin, and you can see that really fine webbing or that mesh-like structure, that's areolar tissue. And it's connecting different structures. So the areolar tissue, at least in relation to the skin, it helps to secure the epidermis down to the dermis, or the epidermis with the dermis. And we will learn here shortly, there's like a papillary layer, and that's where you're going to find some of the areolar tissue. So it's located throughout the body, and it is dealing with holding things together. So you've got an organization of collagen and elastic fibers. It's kind of a cheap one to make for your body. It doesn't take much energy. So that's a good overall structure. And the last one that we will just touch on is going to be reticular tissue. That's going to be a different type of tissue. And reticular fibers is a meshwork of fibroblasts. It forms the framework for organs. Okay, so you're looking at the spleen, lymph nodes are two that it's definitely going to be associated with. The thymus gland is going to be another one on that one. And this provides the framework. We're not going to really look a lot at those. I'll see if I can find a couple slides that will show that one as well. So those are your primary ones. Off of connective tissue proper, we have two subcategories of that, dense and loose. Of the dense, there's going to be three types. There's regular, which are going to be tendons and ligaments. There's going to be loose, which is, there is irregular, not loose yet. There's irregular. This is going to be found like in the dermis of your skin. You have the collagen fibers are in multiple different directions, so it allows for resistance in different directions. And then the elastic tissues, those will be allowing for stretch and recoil, and you'll find those in the structures like the arteries. Okay. Supporting connective tissue, two flavors of this. We're going to have bone, and then we have cartilage. Okay. And for bone, just briefly, once we get into the skeletal system, we'll go into this much more detail. But under bone, we're going to have two different flavors of this. We're going to have, let's go this way, compact. And then do another one here. We're going to have, we'll just call it spongy. Spongy bone has a couple other names associated with it. You can have cancellous bone. That's also another name for spongy bone. Trabecular bone is another name for spongy bone as well. Compact bone, it appears just like what it is. It's very compact. It's very dense in material. Spongy bone, just visualize a natural sponge in your kitchen, and it kind of looks like that. You find that on your internal structure of your bones. Okay, it provides the bones to be a little bit lighter, but gives it a lot of support and stress. The last one we're looking at is cartilage, and then those comes in three different flavors on here as well. Your primary one is Highland. Highland cartilage. Did I spell that right? Hyale. Hyal. Yeah, I spelled it wrong. So let me redo this one. Hyale. Highland cartilage. Okay. And Highland cartilage, that's going to be your primary cartilage that you are going to have in your body. This is what you are typically born with. So a precursor to your skeletal system is made up of Highland cartilage, and then the Highland cartilage converts over to bone. We'll get into that a little bit later. It's the most common one. This is probably one of my favorite tissues because it just looks really cool. You're going to find Highland cartilage pretty much all over. You're going to find it in your nose, your trachea, your voice box, the larynx, the ends of your long bones, on your articular surfaces. Another one is going to be fibrocartilage. And fibrocartilage is weight bearing. Okay, so these are very tough portions of cartilage. You're going to find these as your intervertebral discs of your spine. You can find the knee meniscus. So if you have a torn meniscus in your knee, you're going to be looking at that. The pubic symphysis. Okay, so these are going to be much tougher structures. There's very little ground substance in those. That's good for that one. And let's do the last one. And we've heard this word before. It's a different type of tissue. Elastic. Okay, so elastic tissue is different from this tissue over there and this one. This elastic tissue is allows for some springiness, some flexibility. And you are going to find that, let's say, for the ears. Okay, so the cartilage of your ears, you bend it over and boink, it pops back up. That's going to be the elastic cartilage versus over here, this is elastic tissue. So same word, different, made up of different things and are located in different parts of your body. So that, let me just look at my notes on this part. I think this is good for this part. So the next one, I think I'm going to see if I can find some slides, for histology slides, to then actually show you some of these structures, since we may not be in lab this week. So until then, I shall see you shortly. Let me turn this off here, wherever it's